Okay, let us begin with lecture number 15. This is another application of Pythagoras theorem. Let us start looking at it. Now we have proved Pythagoras theorem for right angle triangle that if this angle is 90 degree ABC, then AC square is equal to AB square plus BC square. Okay, that is what we have already done. Now the question is, instead of this angle 90 degree, AB and C, if we move this distance AB little inside like this, then the triangle would become acute angle triangle, where AB is equal to AB in earlier diagram, BC is the same. Therefore, we just rotate this segment BA little bit inside so that instead of 90 degree, this angle is acute. So what do you think will be distance AC compared to right angle triangle? If it was 90 degree, then that distance AC, if AB and BC are not changed and BA is brought inside little bit towards C, then what do you think distance AC, new distance AC would be? Of course it will be little smaller than the earlier AC. So now let us try to find out this distance AC in case if the triangle is acute angle triangle. So we start with acute angle B and we would like to find out distance AC if this angle is acute. So we draw perpendicular and let that point be D. So if we apply, now we want to find out distance AC. So distance AC square, applying Pythagoras theorem to triangle ADC, we get AD square plus DC square, right? This is the starting point. Now eventually the result that we are going to prove is AC square, which is equal to BA square plus BC square minus 2 BD BC. This is what we want to prove. Starting point is this, there are a couple of steps in between and we should get this result. That is what we were expecting. We need to subtract something from BA square plus BC square, because if this triangle was right angle triangle, then BA square plus BC square is equal to AC square, but then if it is acute, it is little less. So we get this quantity as little less compared to earlier distance AC. So I give you sufficient time, pause this video, try to find out what are the steps in between. It is just application of Pythagoras theorem and doing some algebra here and there. Try to do it, think about it, check your answer with the solution. Thank you. Now, this is first application of Pythagoras theorem to ADC. Now if we apply Pythagoras theorem to ABD, what do we get? AB square plus AB square is equal to BD square plus AD square. Therefore, AD square I can write as AB square minus BD square. Okay, so in the final expression we have BD, AB and BC in RHS. AC in LHS we have already achieved. We want to achieve BA, BC and BD in RHS. AD and DC are not there in RHS, therefore we have to get rid of AD and DC and we have to bring BA, BC and BD. So in case of AD I can do it AB square, or maybe we can write BA square minus BD square. Now how can I get BD, BC or BA in case of DC? That is how we should think. So DC is BC minus BD, BC minus BD, bracket square. So now if I expand that bracket, I get BA square minus BD square plus BC square minus 2BD BC plus BD square. And if I remove that bracket now, will I get this result? Yes. So it was just 2 steps away from, we were just 2 steps away from the final result. Now BD square gets cancelled. So BA square plus BC square minus 2 BDBC is AC square if angle B is acute. Now, how do you remember this? Suppose this is the triangle, and now we are talking about, say, PQR, and if you draw perpendicular S, and now let us write the relationship for acute angle R. So if I am writing relationship for acute angle R, then I am this angle R is very important to me. I am finding out side opposite to R, which is PQ. So the expression would go like this: PQ square is equal to, you start from R, RP square plus RQ square minus 2 RS RQ. This is going to be the formula. So this is the trick to remember this formula that we have derived now, which is called extension of Pythagoras theorem. Now, if we have done something for acute angle B, similar work we should do for obtuse angle. So instead of rotating it towards C, if we rotate it outside, then distance AC is bound to be bigger than in right angle triangle. So now this, once we do acute, obtuse we expect students to do independently. However, I will give you the starting point A, B, C, drop perpendicular from A. Now because it is obtuse angle, the perpendicular is going to be outside BC. This is 90 degree, and that is how we have rotated it outside so that we get AC square bigger. So we want to find out AC square, and the final expression is going to be AC square is equal to BA square plus BC square plus twice BD BC. Pause this video, try to get this answer independently. It is very easy. You do it yourself and check your answer with our answer after you resume. Pause. Thank you. So again, AC square is AD square plus DC square. We don't want AD and DC both. We want BA, BD and BC. So AD square is equal to BA square minus BD square plus, now DC is equal to BD plus BC bracket square. So if you expand BA square minus BD square plus BD square plus twice BD BC plus BC square. Now this BD square gets cancelled and we get the final agent. This is extension of Pythagoras theorem for obtuse, and the technique for remembering it is exactly same. You have angle B under consideration, therefore you are finding out side opposite to it, AC square. Start from BA, BA square, BC square, and because it is obtuse we need to add something, therefore plus sign 2 BD BC. 2 is because of you are completing the square, expanding the square, that is what gives us that 2. So it is very easy to remember. Okay. And now the third thing that we would like to prove in this is Apollonius theorem, in which we have a triangle and midpoint M is given. So triangle ABC, AM is a median, AM is a median. Now we would like to find out distance AM, the length of the median, if we are being given sides of triangle ABC. So our standard notation, side opposite to capital C is small c, side opposite to capital B is small b, side opposite to capital A is small a. So distance BM is A by 2, it is median, therefore these two distances are equal, and we wish to find out AM square. Or maybe we wish to find out relationship of AM square with respect to ABC. Now, important to note that if this triangle is not isosceles, if it is isosceles, this median will be altitude, and it is an easy case because both these triangles will be right angle triangles, and finding out AM square will be very simple. You can find out what that formula is. If the triangle ABC is isosceles, AB is equal to AC. But we are taking the difficult case when AB is not equal to AC, and in this diagram AB is smaller than AC. So what I would like to bring it to your notice is, if AB is smaller than AC and if you join the median, you end up getting this angle AMB acute and AMC obtuse. Okay, so for triangle AMB it is acute, therefore write down extension of Pythagoras theorem for that. In triangle AMC it is obtuse, write down extension of Pythagoras theorem for that, and do little bit of algebra to get the final result. AB square plus AC square is equal to 2 times BM square plus AM square. Pause this video, try to do it yourself. If you get it, very good. Spend good amount of time. If you still do not get it, watch our video. But by now, if you have been working hard, you should be able to do this very quickly. Pause, start. Okay. So AMB, what we have decided is M is acute, therefore AC square is equal to. Now we need to draw perpendicular in this. That is what is the trick. Let that point be D. Then AC square is equal to MA square plus MB square minus 2 MD MB, and it is obtuse, therefore here it is AB square, here it is AC square, which is MA square plus MC square plus 2 MD MC. Now what is so good about MC and MB is that both of them are equal. So if we really add these two equations, then we will directly get the LHS AB square plus AC square, which is equal to 2 times AM square, which is quite visible. BMC is equal to MB, therefore these two terms get cancelled, and these two terms are identical, so I can write BM square or CM square here, and you get the final answer. This is Apollonius theorem. And need to be remembered. Proof is very interesting. Extension of Pythagoras theorem and application of extension of Pythagoras theorem 2 times to any triangle to get Apollonius theorem. Now here AB is known, AC is known. If all the 3 sides of the triangle are given, AB is known, AC is known, BM is half of BC, therefore it is known, we can find out length of the median. And this is length of the median through A. Similar formula we can write for length of the median through B or C, and you can do it. Okay, so this is what, as far as classwork is concerned. There is good amount of homework also. Actually three problems, but third problem is involved. I will just give you some hint for solving the third problem. Suppose I have this angle 30 degree in triangle ABC. Now in the notation that is given here, that the angle under consideration is A, therefore let us call this as ABC like this. Let us keep the notation same. Suppose it is 30 degree, then it is a special triangle. 30, 60, 90 is a special triangle. Therefore the formula will be BC square, that is small a square is equal to AB square, that is C square, plus AC square, that is B square, minus 2 AD AC. So ADAC is AD into small b. Is that right? So the only element which is remaining, which is not in terms of ABC, is AD. But then this happens to be a good angle, 30 degree, and 30 degree we are used to it. We have done good amount of work on 30, 60, 90. Therefore, I can find out AD in terms of AB in this diagram. So if I find out AD in terms of AB over here and substitute, then I will get some constant here and AD will be absent. So if you remember correctly, if this distance is C, BD will be C by 2 and this will be root 3 by 2. AD will be root 3 by 2. Therefore, C square plus D square minus 2 times root 3 by 2 C into B. Therefore, the final formula will be B square plus C square minus root 3 into BC. So, A square is equal to root 3 B square plus C square minus root 3 BC will be the final formula if angle under consideration is a special angle 30 degree. So, we have given you a list of different angles 0, 30, 45, 60, 90, 120, 135, 150 and 180 and created a table. You should prove it in each case that you get the table completely correct. There are 2 more numerical problems, solve them. This is what our lecture number 15. Hope you have enjoyed. Work hard, solve all the problems. Any difficulties, please contact us. Thank you. Let us meet in the next lecture, lecture number 16. Thank you.